Quick review. Two methods you do know to prove triangles congruent. Two methods you do know. Here we go. 27. And there we go. What do we need to know about the angle and side angle side? 9. Never mind. 14. What do we need to know about the angle and side angle side?
Oh.
Hi.
It has to be between two congruent sides.
Correct. The angle has to be in between the two sides. Alrighty. 3 and 4 coming up today. And when you do a proof, all 4 are in play. Could be possibilities. Number 3, ASA. ASA, standing for angle, side, angle. That is the third way of showing two triangles are congruent. Angle, side, angle. Based on our work from yesterday, shocker. Guess what? If you're going to use this method, what do you need to know about that side? Has to be in between the two angles. Has to be in between the two angles. If it's not, today that's okay. If it's not, it's okay because we have a fourth method which says if the side's not in between, we have AAS. Now look at where the side is. Not in between. And we can use angle, angle, side. So let's just basically sum up this here. If you have two angles and a side, you're good. You just have to figure out which method of the two it is. All right, so if you have two angles and a side, triangles are going to be congruent. It's just a matter of what method it's going to be. So here's the deal today. I'm going to do 2 proofs with you, and then I'm going to do a proof that's not in your packet that you and your group are going to try to figure out yourself, and that proof might be the toughest one we do all year. So we'll see what you're made of, you and your group. All right. So let's get warmed up first before we hit that proof up. Oh, so sorry. I didn't write the givens in or mark the diagram for you today. Sorry. Suck it up. Here we go. The softness is gone. Did I give you any congruent pairs? I did, right? I gave you a pair of angles. Everyone agrees? I gave you a pair of angles. So at least we have one pair of congruent parts. You guys now are going to help me find 2 more. Okay, I got a pair of angles. You need to help me find 2 more, whether that's something on your own you can see on the diagram or something that I gave you. Ready? Let's do this. Where's the second pair going to come from? Oh, 25.
Angle SQR equals SQP.
Okay. Yep. Angle SQP has to be congruent to angle RQS because angle PQR is getting bisected. Definition of bisects. I'll mark it on my diagram. And now that counts as an angle. This is also another reason why I like marking the angles and sides as I go along. I know for a fact the next thing somebody gives me has to be a side. Why? May?
Because there can't be an angle.
And there never will be. There never will be angle. So you know it's got to be a side that you give me next. So that if you're ever stuck, oh, I know it's a side, so darn it, search for a side. Forget about the other angles. So where's this side coming from? 21?
SQ, congruent to SQ.
There you go. The reflexive they share. Jack, you were all over that, right? And honestly, I think this is the hardest part of the proof right here. Angle, angle side, or angle, side, angle? That's what we got to determine. How do you determine it? Cover up one triangle and say to yourself, is that reflexive side in between my angles or not? Is it in between or not? And that'll tell you what method we're going to use. So I just recopy my proof statement. Triangle PQS congruent to RQS. And you guys let me know, what method out of the two do you think it is? Oh, 22.
Angle side.
That side is definitely in between, so it's going to be angle, side, angle. Any problems on a basic one? We'll go a little more advanced before we go hardcore. Oh, what do we got coming up next? Go ahead, get all your givens and mark your diagram, and then this is why I have colored pencils on everybody's group today. Your diagram's a little more complicated. Look at the two triangles I'm asking you to prove congruent. ACD with ECB. They overlap each other, don't they? It might be hard to see some of the parts. So that's why I have the colored pencils, and I'm suggesting, you don't have to take my suggestion, but I'm suggesting highlighting both triangles in two different colors so you can definitely see what sides and angles belong to each triangle. So I'll give you a minute to do that if you choose to. Let's start with the givens. Did I provide any corresponding parts to you? Let's see. DAC. Everyone take a look at DAC. Is that a full angle in one of my triangles? DAC, is that a full angle? Yes. BEC, is that a full angle in one of my triangles? Okay, so I basically started you off here with a pair of angles. I can count that as angle. And it just helps me see it better when I highlight them. All right, what about these line segments? DC and BC. Is DC a full side in one of the triangles? DC, is it a full side? Yeah, no? It's not a full side in triangle ADC? It is, right? And what about side BC? Is side BC a full side in one of my triangles? Yeah, and it makes it easy for me to do this when I highlight it. I can see by the colors that they're full sides. How many more do you need to find? One more. That's it. You just need to find one more on your own. And haven't we used, we've used both the given, so this might be something you need to find on your own by looking at the diagram. So I'll let you search, maybe discuss it in your group. It's not a new reason, but we've never used this statement with this reason. So some of you might be questioning yourself, don't. Is there anything else you can see that might be true between these two triangles? Find anything. Any groups find anything that you're confident in? John, what's your group find? Okay, vertical angles. That is true. Here's my issue though. Is angle AFB an angle in either of these two triangles? Right? So I can't use it. It's got to be a full angle in one of the triangles. So if you wrote that down, it would be correct, and I would not mark off for it, but you can't use it. Right? I can't put an A next to it because it's not a full angle in either of my triangles. Andre.
Reflexive angles.
Which one?
C.
Everybody, hey, take a look at angle C. Is that a full angle in both my triangles? Yeah. And I know we haven't done this yet with the proofs, but an angle can be reflexive, just not sides. Angles can be reflexive. Now comes what I think is the hardest part. Angle C might have been tough for you, some of you to see, but I think this is the toughest part. Is determining the method because these triangles overlap. Is it ASA or AAS? This is tough. And I'll fully admit, it's tough for me to see if that side is in between or not. So here's what I'm going to suggest. I do this all the time. If you're having trouble finding the method, take one of the triangles and draw it out separately. Separately. So I'm going to take triangle ADC right here, draw it out, and I'm going to put all the markings I have on ADC up. So I have angle A marked, right? Everyone agree? I have angle C marked. And what side do I have marked? What side do I have marked on triangle ADC in my original diagram? DC. Becomes pretty easy now. Is that side in between? Is DC in between these two angles? It's not in between. Draw it. I know. So here, and again, here's the problem, guys. You guys see this side here is in between these two angles, but you're looking at two different triangles with two different parts. Draw the darn thing out so you can see it. All right. It makes it very, very easy when we do. Questions? All right, here we go. We're going to honors level now. This is where the expectation is to be at this on today during today's class. Go to close up your packet. You got a nice white space on the back. You know the deal. Call me over if you and your group think you have it. Try to work together, please, so I don't have to check 3 different proofs in one group like I had to do last period. Try to work together. If you're stuck, call me over. But here it is, the big dog. Yep, there it is. Good luck. God bless. And I at least can tell you, you will not put anything in the reasons column we haven't used. You will put stuff in the reasons column we have used throughout this year. Now, maybe one of the reasons or 2 we haven't used in a couple weeks, but we've used them. All right. If you and your group are totally stuck on finding an angle or a side, let me know. We'll work through it. Great proof right here at this point in the unit. Great level proof. This is where we need to be.
No, wait, stop. Wait. Are we creating? Oh. Is it like that, like addition? How's it addition? Because of the, I don't know. I can write that. You can write that. I think it's the pose of like the 4 to 5 supplements.
Keep track. Make sure you keep track. Make sure you keep track of the angles and sides you have. Again, try to work together as much as possible. I don't want to check multiple proofs in the same group.
Yeah.
It's
So
the-
360.
Oh.
Oh,
Oh, wait, no.
three
Just let me stop this real quick.
Oh,